Right, we're ready for section 7.7 on applications of systems of linear equations. You may notice 7.6 got wiped out. I decided to cut that out because of time constraints in the condensed summer session. 7.6 is all about solving systems with 3 equations or more, and thought that would be something that some of you will not run into in your future. If you do take finite math, you'll start with systems of 2 equations and move up to 3, so you'll get that again. If you take Math 180, college algebra with trig, you won't run into it at all. So yeah, so here we are with applications. Everybody's favorite, right? We have 4 of them. You'll see some similar to these types in your MyLab homework. First one is a kind of a geometry application. It's talking about a triangle. So we're told, let's just draw a picture. We're told something about the perimeter. Let's draw a triangle. Oh, hold on a second. I'm going to read the whole thing. 2 sides of the triangle have the same length. So that's going to be helpful, I think. So I'll draw a triangle with 2 sides the same length. That would make this an isosceles triangle, right? So let's say these 2 sides are the same length. I'll call them x and x. This other side, we don't know. I'm going to call it y. Okay? And then let's start writing some equations. So the perimeter, we're told, is 70 centimeters, right? So the perimeter is the distance around x plus y. Or x plus y equals 70. We could write that in a simpler way, right? We could say x plus x is 2x, so 2x plus y equals 70. So that's one equation. We're also told that this third side, this y, is 7 centimeters longer than either of these sides. So as an equation, that would tell us that y is equal to x plus 7. So really, these 2 equations represent our system, and we want to solve that system. Since one of these is already solved for y, I think substitution might be easy to use. So I'm going to take this x plus 7, plug it in for y in the other equation. So then I get 2x plus x plus 7 equals 70. Now I have only one variable, and I can solve for that variable. 2x plus x is 3x, so 3x plus 7 equals 10. Subtract the 3 and I get, or subtract the 7 and I get 3x is equal to 3. Oh wait, that's 70, not 10. Alright, subtract the 3 and I get 63, right? 70 minus 63. Okay? So 3x equals 63. Divide by x, or divide by 3. 63 divided by 3 is 21. So x is 21. And since we're measuring in centimeters, that's centimeters, right? So this is 21 centimeters, which means this is also 21 centimeters. And y is 7 more than that, so 21 plus 7 would be 28. If we add those 3 together, we can check to make sure that equals 70, right? 20, 40, 60, 8, 9, 10. 60 and 10 is 70, so that works out. Now, what were we asked for here? Find the length of the equal sides of the triangle. So 21 is the answer we're looking for. If we were asked for the other side, we could say it's 28 when we can verify our answer. But in this case, we're only asked for the equal sides. So 21 centimeters would be our answer. Okay. The next one. This is a Men in Black reference, I believe. And some of you are probably way too young to know that movie, but so you can still follow the problem. So while on a stakeout protecting Earth from the scum of the universe, Agent K observed 5 men in black enter a coffee shop, and they had 3 donuts and 5 coffees for $3.30. Next, there were aliens disguised to enter the shop and got 4 donuts and 3 coffees for $2.75. Finally, Agent Zed from the home office entered and got a donut and a cup of coffee, and we want to know what his bill was. Well, if we knew how much a donut cost and a cup of coffee cost, we would be in business. We could just add those together, right? So let's make those our variables. For D for donut, and some people spell donut a different way because Dunkin' Donuts, D-O-N-U-T. I'll spell it this way. C, hiccup of coffee. We need to find those costs. There's a cost of each, right? Well, this first information here, doesn't matter that there are 5 men in black. Not really. We just want to know how the prices are related. But so we get 3 donuts, right? So this equation, 3 donuts, 3 times the donut cost, plus 5 coffees, 5 times the coffee cost, should equal $3.30. The second group, the 3 aliens. Does it matter that there are 3 aliens? No, not really. Could be any number of aliens. They got 4 donuts and 3 coffees, and their bill was $2.75. So using these 2 equations, we should be able to figure out the cost of a single donut and a single cup of coffee. So you might ask yourself, am I going to use substitution? Am I going to use elimination? Since these are both in standard form, I would probably use elimination. Let's try to make these 2 variables opposites. 3 and 4 both go into 12, so I'm going to make one of them 12 and one negative 12. Let's multiply the top equation by 4 to make that a 12. And we want to make this a negative 12 then, so let's multiply the top or the bottom equation by negative 3. And we'll get our 2 new equations, right? Alright, so we have 12D plus 20C and 330 times 4. I want to make sure I get this right, so let's see, 330 times 4, that's $13.20, $13.20, right? And the bottom equation, we have negative 12D minus 9C, and let's see, 275 times negative 3, that's negative 825. Then we can add those equations together, right? The D's are eliminated. C's, we get 11C. And we add these 2 together, 1320 minus 825, that's 495. And we divide by 11, and we should know how much a cup of coffee costs. 45 cents. Pretty cheap, right? You can tell it was an old movie. So, 45-cent cup of coffee. Now, to figure out how much a donut costs, we have to take this 45 cents and plug it in for C in one of our original equations. Maybe I'll use the first one. Ignore the 4's there. We have 3D plus 5 times 0.45 equals 330, right? Now we only have one variable, the D. 5 times 0.45, what is that? That's 225, right? So 3D plus 225 equals 330. We subtract the 225, so 330 minus 225 is 105. So we get 3D equals 105. And we divide by 3. Let's see, divide by 3. We get 35 cents. Donut for 35 cents. Not bad, right? So donuts cost 35 cents. Coffee costs 45 cents. So, answer the question. Agent Z bought a donut and a cup of coffee. So we just have to add those 2 together to figure out his bill. So 45 cents, so 0.35 plus 0.45 gives us 80 cents, right? We add these 2 together, and Z's bill was 80 cents. Alright, so there's a good example application that used elimination. Now the next one, these can be some of the harder problems, the mixture problems, but I'll try to help you a bit. We'll do this example anyway. So a pharmacist wants to add water to a solution that contains 80% medicine And the goal is to get 12 ounces of a solution that's 20% medicine. We want to know how much water and how much of the 80% solution. So let's let X be water and Y be the 80% solution. And what we'd like to do is try to get 12 ounces, right? Well, that's the easiest equation. If we add X plus Y, that'll give us our 12 ounces that we want. So those are the amounts, X milliliters or whatever it is, plus Y, ounces. X ounces plus Y ounces equals 12 ounces, right? The next equation is a harder one, but it's the concentration equation, basically. This equation really represents the amounts, and the next one is going to represent the concentration of both of these things. So what's the concentration of the water? Well, as far as medicine goes, it's 0, right? So we have 0 concentration for the water. The 80% solution is 80%, so that's 0.8. So I'm going to write 0.8 concentration times the amount, Y. And what we want to end up with is a 20% solution, right? So 0.2, but that's 0.2 of the total amount. And the total amount is really X plus Y. And this is the part that really throws people usually. But that final solution concentration is 20% of the total amount. And we added X plus Y to get the total amount. Okay. Well, we know that's actually 12, right? So we can simplify things a little bit. This equation is really 0.8y equals 0.2 times 12. We really use substitution. X plus y is 12, right? Okay. So this one is still X plus y is 12. 0.2 times 12, this one becomes what? 0.8y. 0.2 times 12, what is that? 0.2 times 12, I should know that. 2.4, right? Equals 2.4. And then we still have X plus Y is 12. Well, this becomes even easier here, right? Because we can solve for Y. Divide by 0.8, and we get 3, right? So if we divide by 0.8 here, we get Y is equal to 3. All we have to do is plug that in here to find X. Well, what plus 3 is 12? X has to be 9, right? Yeah. So if Y is 3, X is 9. 9 ounces of water, 3 ounces of the 80% solution, and we're in business. Okay. So that's not terrible. It might look terrible at the beginning. Again, the part people often mess up is this part here. This final solution is 0.2 of the entire amount, the water plus the 80% solution. All right, we have one more to look at here, and this one is kind of a fun one, I think, maybe. So a farmer has some normal pigs and chickens. I say normal because we want to assume they all have a head, and they all have the appropriate number of legs. One day he noticed that his animals have a total of 42 heads. Well, since every animal has a head, I'll use P for pigs, C for chickens. The pigs plus the chickens should equal 42, right? Pig heads plus chicken heads. So, and I'm assuming they all have a head. Okay, that's why we assume they're normal. 122 legs. Well, how many legs does a pig have? 4, right? So 4 times the number of pigs. So this is going to be an equation for legs, right? How many legs does a chicken have? 2 last time I checked, right? So 2 times the number of chickens should equal the number of legs, 122. And now we could use substitution or elimination, whichever one you like better. I think I'm going to use elimination. I'm going to eliminate the c, which means I need to multiply this top equation by a -2. This one is a +2, right? Multiply by -2 by -2. And so let's see what this new equation looks like. We have -2p minus 2c equals -84. Here we have, this one's just going to stay the same. 4p plus 2c equals 122. And let's eliminate the c's now. -2p plus 4p is 2p. C's are eliminated. Negative 84 plus 122. What is that? 122 minus 84. 38, I think. Yeah, 38. All right. Then we divide by 2, and it should tell us the number of pigs. Right? So 38 divided by 2 is 19. 19 pigs, right? So now we need to figure out the number of chickens. Well, we could go back to this original equation. Pigs plus chickens is 42, right? So 19 plus chickens is 42. We just subtract the 19, and 42 minus 19 is 23. So 23 chickens and 19 pigs. And we have used elimination and a system of equations to solve this problem. Okay, so that's it for this week. I hope you've enjoyed the videos. If you made it this far, congratulations. We will pick up next week with Chapter 8.